Okay, FST. This is the video for 8.4. The same day as you're going to be taking a quiz is what you're supposed to watch this in preparation for. So just to let you know how class is going to go, uh, I'll have a do now before the quiz that's going to have problems on it from 8.1 to 8.3. Because your quiz is going to be over 8.1 to 8.3, and that is about everything but from like what is a sequence to the difference between arithmetic sequence and geometric sequence, recursive and explicit formulas. That was all 8.1. 8.2 was about limits and what a limit is, and then 8.3 was how to add up terms of arithmetic sequence. Okay, so we'll go over some of that before the quiz starts. All right. Then what you're supposed to know after the quiz and after you watch this video, oh sorry, you can't really see all of this very well, there you go, is that just kind of like when you came in on Thursday, that you should be able to discuss in your groups these couple of learning targets. So have a look at this. This is about adding up geometric series this time, which you may be able to predict is going to be a lot like the same kind of process as adding up arithmetic, just a slightly different formula, and you'd be exactly right. Okay, let's look at that. All right, geometric series. This is, as you might think, okay, that's weird. That thing is there again. How do I get rid of that? Click off it? Yeah, okay. Well, it just moves. No. All right. For geometric series, this really isn't going to take long. Geometric series are the series are like this, where you're adding up strings from a sequence where things have been multiplied constantly. We have 2, 6, 18, 54. That means each one has been multiplied by 3 to get to the next one. The explicit formula for this one is seed value times constant multiplier to the power of n minus 1. If you think about that, then that would turn 1 into 2, 2 into 6, 3 into 18, and 4 into 54, etc. So then the next thing we're going to be wanting to do is figure out, okay, if someone asked you, add up the first 10 of those. How would you do it? And guess what? Yes, there's a formula. And just like before, I'm not going to go into a long explanation of why this turns out to be, oh, where's the formula? You ready for it? This, here it is. Here's the great big formula for today for adding up geometric series. I talk about it a little bit here. Adding up the nth partial sum, which means the first n terms of the geometric series. It's kind of like when we did it for the arithmetic series. There's a trick about this, about how to get from here to here. But really, this is the thing we got to internalize. So let me just jump to doing some problems. Oh, but before I do that, I realized that they've snuck in the sigma notation again. In fact, the sigma notation came back a little bit when they started talking about arithmetic sequence or series in 8.3, and this just means we're going to take the sum of the first n terms of this sequence, which is, I mean, they use Sn too. It's saying we're going to take the sum of the first n terms of, and here you go. This is how you do it. This means this is actually saying what the the explicit formula for the sequence is right here, and then the formula for how you find the sum is this right here. So let me do some problems. Okay, so I just rewrote those two things here. If we're trying to find the sum of, as the sigma means, the sum of the first n terms of this this sequence, that would mean that kind of tells you some things here, like g sub 1 always stands for the initial term, like the initial value. Maybe if I can write it. Okay. The other ingredient in here, the other big thing to know, really the only other thing to know here, is R, which is the constant ratio, the thing that's being constant. Can you see that? Sorry. Ratio, which is the thing being multiplied over and over and over and over again to go from term to term. The term to term same multiplier. If you know all those ingredients, then you have enough information for this. N is how many you want to add up, and that shows up over here. G sub 1 is the first item in the sequence, and R is the multiplier over and over again. This will tell you how to add up the first n of those. So one question we might get is add up the first 10 of these. That would be 1 plus 3 plus 9 plus 27 plus 81 plus blah 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 up to the 10th one of those, which is, I don't even know what that is, and I don't need to know for this. In order to find S sub 10, I just have to plug this in. What's the first value? The first value is 1, and often it is. Okay, then I always go 1 minus r. What's the r here? What's being multiplied each time? This is a times 3 sequence. 3 to the nth power, this is n. 3 to the 10th over 1 minus that r again, which is that ratio there. So this is 1 times, that kind of goes away, 1 minus, wow, that's a big number, 3 to the 10th power. Let's get the calculator out. It's a slightly different calculator than you've seen before, but it works. 3 to the 10th power is 59,049. Don't let these big numbers scare you. Over, now you're going, whoa, that's going to be negative. Well, so is this. So we're talking about 59,000, negative 59,048. That's nice. It's an even number divided by negative 2. Go back to the calculator. Minus 1 divided by 2. And this is the same thing because now everything's just positive. 29,524. Great, because I really didn't want to have to find all those things and add them up. Now, I gave you this problem in terms of here's the sequence, find how to add it up. Sometimes they'll give it to you in this format. So let's do another one. I'll just say find the sum of the first 8 terms of the sequence 1/2 times, oh, I don't want to use 3 again. How about 4 to the n minus 1 power? Now, the fact that this is a sum of a sequence, that there's a number here times something else that happens to be the n minus 1 power, you're supposed to go, oh, I know what that is. That's a geometric sequence. I'll use my geometric sequence. My geometric series, I keep doing that, my geometric series formula, which is this big thing. And then from that you have to read, okay, what's g sub 1? Well, g sub 1 in this whole thing, if you forget, you can put 1 in here for n and see what happens. Notice if you put 1 in here for n, you'll always have something to the 0th power, and this all kills each other off, and all you're left with is this half. So that's g sub 1. This is 1 minus something. I'm just trying to make you remember this formula. And r goes in both these places. R here is going to be 4. It's the thing that's being multiplied over and over again. And instead of n minus 1 now, I put n. Remember the formula here in general is 1 minus r to the n. There's no minus 1 there. And part of that has to, it's kind of like this when the same thing happens in the arithmetic series. Again, I didn't really prove that, and I don't feel really great about that. Ooh, I left that as n. I know what n is now. I don't have to say n. I was all excited about how it's just n and n minus, not n minus 1, and I forgot to actually tell you that n is 8, or, you know, use my n is 8. Half times 1 minus, oh man, 4 to the 8th power. 65,500. Okay. Divide that by 1 minus 4. This is negative 3 downstairs. And this, you start to see this kind of thing happens over and over again. 1/2 of that big mess. I'll do this. 1 minus big mess. And I need half of that. That's negative what? I have a fraction. That's all right. Negative 32767. And if I want to divide that by 3, that's not going to be pretty. Divided by negative 3. And I get 10,922.5. Now it's not that weird that we're getting a half here. I mean, we're taking half times 4 to some power. If you wanted to know what that sequence looked like, what we're really talking about here is the sum of, so I'm going to write these terms and put plus in between them, so this looks right at the end. The first term we said was half. The second term, that's why I made a plus, this is actually g sub 1 right here. G sub 2 is a half times 4 to the first power, because that's 2 minus 1. Half times 4 to the first power is really just a half times 4, which is 2. But then the next term is going to be half times 4 squared, which is going to be half times 16, which is 8. And then we have half times 4 cubed. Well, 4 cubed would be 64. Half of that's 32, plus bloody bloody blah. We're going to get a whole bunch of stuff here. These numbers are going to be whole numbers increasing, I think, because they're powers of 4 cut in half. Those are always whole numbers. But guess what? There's this half stuck on the front, and there's where it shows up there. Kind of nice. That's predictable. And that's about it. I don't want to waste your time. I know your time is precious. You got a 3-day weekend. Enjoy that. Of course, it's probably over by the time you open this if you're like most people. Anyway, make sure you study for the quiz. Again, it's going to be 8-1, 8-2, 8-3, which is sequence series, sequences in the first place. What is a sequence? What is a limit? How do you determine the explicit formulas for arithmetic and geometric? How can you recognize if it's arithmetic or geometric? By now, you have plenty of practice problems and videos to watch. Thank you. See you Tuesday.